Hi, this is Clifford Carnicom from the Carnicom Institute, and today I'd like to introduce you to a model, a software project I've been working on entitled a climate change model. This software project is an attempt to simulate the effects of changes in the growth or decline rates of the greenhouse gases, namely carbon dioxide and methane, and also the introduction of various aerosol types into the atmosphere. The video today will be a tutorial strictly and primarily at least on the mechanics of the program to introduce you to the controls and how to use the program. And a subsequent video will discuss various scenarios, analysis and interpretation of this model, as well as the physical and mathematical basis of the model in more detail. So today is just one of introduction to the program structure. When you go to the program interface, you'll see on the left side, the column on the left will be devoted to the greenhouse gases, carbon dioxide and methane. You will have certain sliders available here that will allow you to set both the growth rate and the decline rate of those gases. On the right side of the program, you'll see a panel for various aerosol types and or water types being introduced into the atmosphere. So to get started on this model, you would make some type of change in something. You can actually change anything in any combination you want. The model is simulating very small differences within these effects that have a fairly large impact. So you want to start with fairly small numbers before you stretch it to the max, because you'll simply exceed any kind of range of expectation. So let's say you wanted to introduce an increase in the growth rate. This is the growth rate of the concentration of carbon dioxide into the atmosphere. If you were to introduce that change with the slider to plus 2.2%, say, you would hit this button down here. This is a button down here that will allow you to submit your changes to the model. So go ahead and hit that button and you will see a graph appear. Okay, and this graph will show you three pieces of information. It will show you the magnitude of the change, the direction of the change, and also a time factor associated with the change. Let me go ahead and step this up just a little bit more to get a little bit larger number. And let's go ahead with this. Okay, so the direction of the change is indicated by a colored bar, red indicating heating and going upward, and you'll see a blue button for cooling and going down. So that is the direction of it. The magnitude will be a bar that'll range somewhere between 1.5 and minus 1.5% scaled out. And the last piece of information you get will be the time factor involved. And this is a large change that I've introduced here. And you'll see down here it'll give you a time factor relative to affecting a 1 degree change, an increase, or a change actually, in the temperature of the air. So you'll have three things that will vary on you with any scenario that you choose: magnitude, direction, and time. There's a button here that allows you to go back to your previous screen and save your values. The same thing will happen for the other. Let's say we were to decrease again. You want to work with fairly small numbers here. Let's say you went to some carbon dioxide, and then let's get that reference value here so we understand where we are. That's at 0.09%. If you need the number, the bar graph will translate that for you visually. And so you'll see that change is smaller, so therefore the magnitude is smaller, and the amount of time is considerably longer, 780 years, to affect that kind of change of 1 degree. Now, going back, if you were to add some methane to this, you should see that value increase, and it did. It went from 0.09 to 0.22, so two things happen there. the magnitude of the change increased, and also the time. Since the heating was increasing, the amount of time to affect that change is less, and it dropped from 700 to 300 years roughly. So again, we're just trying to get to the mechanics of the program, and you'll find that you can both increase and decrease these gases. And I'll put in a positive and a negative. Positive on the CO2 and negative on the methane. There are many, many interesting scenarios that start to develop with this use of this program. Let's knock down the methane a little bit more, and we're almost at the 0 point. Again, we'll talk about that a little bit more later on. Yes, and we've actually crossed the 0 point there. So we'll save those discussions for another time. But a couple other buttons here that are helpful to see. One would be if you want to reset your values to 0, you have a button down here that will allow you to do that. Okay, so if we want to change something and then get back, we can do that easily enough. And let's put in large amounts there so that we see what that does. And that would be 3. Now, if you wish to save your values, you see I have 3 things set there. If you wish to save your values, you can hit this button here, Save Data. In fact, I'll slide another one up. If you hit Save Data, it'll hold your values for you in your cache on your browser. And if you were to reset the program back to 0, you then have the option of loading that data back up, and you can do this at any time you wish in the process. So they're all set at 0 now. You can load that data and you'll get those numbers back into the system. And then you can repeat that scenario. So this allows you to test a scenario, save that data for interpretation of it or study of it, and then coming back to it at a later time. There's a button down here at the very bottom that will allow you to start the whole scenario over from scratch also if you wanted to clear it all out that way. Okay. And on the aerosol side, let's say we were to introduce aerosols. There are 9 different types that have been given to us to play with. And again, I'm going to save the sort of discussion of the physics and math of this till another video. But there are many, many interesting things going on here between the heating characteristics of a material as well as its reflectivity. And so it's this model attempts to combine both of these. This is a model. Nothing is intended to be perfect, but I have attempted to make this a rather realistic interpretation of how various components act in different ways. So you could set, say, 2 or 3 aerosols in here, and you could affect that change into the system. Okay, and that actually had very little change in that particular case. Now, there's another reason for, or another way in which these aerosols are affected. The sliders here are affecting the concentration of a single time where these aerosols are being injected. This slider down here simulates the fact that a person might do this more than one time or even hundreds of times. And so the magnitude of this will be directly affected by how many times somebody does something. Okay. Let's go ahead and see if we get a result there. Right. So if we increase the number of times that somebody performs that operation, then we will start to get some impact from it. And these are just variable quantities. And you'll see those starting to increase. Okay. That about does it for the at least the mechanics of the program. A couple things to look at. You'll have a couple interesting graphs going on here at the bottom. You'll have this video tutorial. You'll have a description of the basis of the model on a separate page here, which is in progress. And you on the output screen, you'll have also a little bit more text information here that can help you interpret the scenarios that are going on. You have some other interesting graphs that are relevant or will be discussed more at later times. So thank you very much for your time. Hopefully that's helpful to get things started, and I'll continue in more detail on a second video. This is Clifford Carnicom from the Carnicom Institute, and have a great day. Interface, you'll see on the left side, the column on the left will be devoted to the greenhouse gases, carbon dioxide and methane. You will have certain sliders available here that will allow you to set both the growth rate and the decline rate of those gases. On the right side of the program, you'll see a panel for various aerosol types and or water types being introduced into the atmosphere. So to get started on this model, you would make some type of change in something. You can actually change anything in any combination you want. The decline rates of the greenhouse gases, namely carbon dioxide and methane, and also the introduction of various aerosol types into the atmosphere. The video today will be a tutorial strictly and primarily at least on the mechanics of the program, to introduce you to the controls and how to use the program. Hi, this is Clifford Carnicom from the Carnicom Institute, and today I'd like to introduce you to a model, a software project I've been working on entitled a climate change model. This software project is an attempt to simulate the effects of changes in the growth program, and a subsequent video will discuss various scenarios, analysis and interpretation of this model, as well as the physical and mathematical basis of the model in more detail. So today is just one of introduction to the program structure. When you go to the program